When I try to dance, I look like a doofus because I haven't practiced enough. Fortunately, I've practiced math a lot. As a student, I worked every assigned problem in all my math and science courses. Many problems I worked twice. Without practice, watching these videos won't make you any better at math than watching Dancing with the Stars will make you a better dancer. Okay, now we're having a look at section 12.5, number 32, and you should be aware that I've changed the numbers a little bit so as not to deprive you of the opportunity for practice. So it wants us to describe the region of R3 represented by this inequality, and we're going to use the same idea, problem-solving format that you may have seen in other classes. In other words, first we want to identify the big idea we need to solve the problem. Then we want to develop the solution to the problem. In other words, we want to make a plan and possibly draw a picture. And then we want to evaluate our plan or execute our plan. And then we want to step back and assess, use some common sense ideas to see whether or not our solution is likely to be right. Does it make sense? Did we actually answer the question that was asked? So first we want to identify the big idea. And the big idea here is, well, one idea is, what is R3? Well, R3 is just three-dimensional space, and it's the fancy language that mathematicians use just to describe three-dimensional space, and we have an inequality. So the general approach that we're going to take is we're going to determine what the surface is and which side the region of interest is on. Alright, so that's our big idea. And then D, we want to develop or we want to make our plan. So one of the things that we need to do is we need to figure out what kind of surface this represents in three-dimensional space. So we can use a technique, so let's make our plan, to complete the square. In the coordinate z. In other words, this is sort of suggestive of a sphere, right? If we had x squared plus y squared plus z squared is greater than, say, 1, then that equality would represent a sphere of radius 1 centered at the origin. So because we have 1 as a coefficient of our x, our y, and our z component, we're sort of expecting this to be a sphere, but since we have this other term out here, we're expecting that when we complete the square, the center of the sphere is not going to be at the origin. So we're completing the square in the coordinate z, and this is going to help us to determine the center of the sphere. And then we need to think about, are we inside or outside of the sphere, and we need to describe region in words. All right, so what we do for the technique of completing the square is first, let's bring the 4z over to the left side, and let's write this as x squared plus y squared plus z squared minus 4z plus blank is greater than blank. And just to remind you why we're putting these blanks in here to complete the square, is the way that you complete the square is you want something on the left that's a perfect square, so then we can write that as like z plus something squared or z minus something squared. And if you add the same thing to both sides, you haven't broken any rules of algebra in that process. So if you think about this for a while, well, the x squared and the y squared are just going to carry down, and then we want z, and it's obviously going to be minus something squared. And as we plan what to put in here, what if we did z minus 2? Z minus 2 squared would give us z squared minus 4z plus 4, so we could add 4 to both sides. And now we can zoom out and think about what we have. Well, let's compare this to more the generic equation of a sphere, right? The more generic equation of a sphere is x squared, let's not center it at the origin or necessarily have any of the coordinates equal to 0. It would be x minus k squared plus, actually I think they usually use h here, right? X minus h squared plus y minus k squared plus z minus l squared equals r squared. So what this would be a sphere centered at h, k, l with radius r. So by comparing, we can see that what we've got here as our boundary is a sphere centered at, well, the x-coordinate 0 because that's just like x minus 0 squared. For the same reason the y-coordinate 0, and then the z-coordinate of the center is 2, and the radius is 2 because the square root of 4 is 2. So now we just need to consider our inequality and whether or not the region of interest is outside the sphere or inside the sphere. So since we're really interested in the region that's greater than 4 here, where the region of space of interest is the region outside the sphere. So to complete our description in words, is where the inequality, the original inequality describes the region outside our sphere of radius 2 centered at 0, 0, 2. All right, so let's back up a minute. We identified, we developed, and this was the point where we started to evaluate here, and this was our answer. Now let's think about, well, how would we assess whether or not the answer makes sense? Well, zooming out, we think about, did we answer the question? Well, the question was to describe the region represented by the inequality. So we're expecting that the region, because it's an inequality, and just like two-dimensional regions that are represented by inequalities end up extending infinitely, at least in some direction, if not in all directions, we have a region outside of a sphere, so it keeps extending in all directions. So we've at least described it in a way that's consistent and that makes sense with the information we've been given.